In this lesson, we'll apply some formulas to the top and back subcomponents. All right, so let's take care of the top and back. So I'm going to go ahead and jump to the top. So I'm going to double click in here, click on my top. And or actually we'll do the back first. And I want to apply some positioning. So the first thing I want to do is I want to make sure that when we're adjusting and flipping the size of this guy, I want to make sure its position is always going to reference or be placed on correctly in the green axis. And that means basically it needs to be what my depth is that I specify, my cabinet depth. So what I'm going to do here is simply jump here to my positioning. And I'm going to say equals bookshelf, exclamation mark, cabinet depth. And again, this should remain in its same position. So I'm going to go ahead and hit tab, and we're in good shape. We're exactly where it needed to go. So nothing for the Z. I don't want it to move up and down. Don't want it to move left and right. I just mainly want to control this going by the depth. So now we could actually come out to sizing. And now sizing, we can now go ahead and take care of that. So I know, first off, we want it to be 1/4 inch, right? So in the Y direction, basically is going to be our thickness. So I'm going to say equals my 0.25, and I'm just going to always keep it that unless I have another value or list, but mine's always going to be 0.25. But if I want to control what's going on in the left and right direction, I always want the sizing this way to match the width along my red. I need to go ahead and put a parameter for that. So I'm going to go ahead and highlight, I'm going to hit equals, and I'm going to reference my bookshelf like we've been doing, exclamation, and I always want that to be my cabinet width, right? C-A-B-I-N-E-T, width. So go ahead and hit tab. No warning messages. We're in good shape. It remained at 60. Perfect. But I also want it to be able to be flexible going in the Z direction, up and down, or basically the height. So again, we'll say equals bookshelf, exclamation mark, cabinet height, tab, 60, no problems, we're in good shape. So now let's take care of the top. So top one's going to be a little bit different here. So we know the top, we have this taken care of. So for the top, we want to adjust its positioning as well. So that one, we want that to be set to whatever our height is for our cabinet. So let's go ahead and do the positioning first. So right now, if I look at this, its top positioning, its Z positioning is set to 60 inches, which is from here to here is 60 inches. So we need to go ahead and make that equal to our bookshelf, or our height, minus our material thickness. If we didn't minus the material thickness, it'll actually have it sit up on top. So I'm going to say equals bookshelf, exclamation mark, cabinet height, minus bookshelf, exclamation mark, the bookshelf material thickness. Alright, so once we have that in place, hit tab, and if you see something, got a little issue here, not a problem, so we'll say equals up, where's my spelling here, bookshelf, so we go ahead and say shelf. So hit tab, we shouldn't get a message, and we're actually in good shape. But really, you see what happened here is we've got this guy placed up here like so. Now, if you wanted it to actually go flush up on top, we can do so by adjusting this a little bit. We could just say it's our cabinet height. And I think that's the route I want to go. So I'm going to go ahead and say that, erase that, and we'll say tab, and it's going to maintain that position. So you can see the kind of the benefit of kind of working here and then watching here. You can kind of almost in a way kind of design here and see what it looks like. So got that taken care of. So I'm going to go back to my top. Let's see if there's anything else. We've got our positioning good. I definitely want to control the size, right? So let's say on our x-axis, we know what we want this to be. And this is going to have to apply that 2 times material thickness, right? Because we want this to fit in between these two pieces. So let's go ahead and do that. So for this one, I mean, our end result should be geometry in the same place and this 58.5. So I'm going to say I want that one to equal bookshelf, exclamation mark, my cabinet width, minus parentheses 2 times bookshelf material thickness. So we should be in good shape once we close the parentheses and hit tab, and we are. We maintain that 58.5. We're at good shape here. So let's take care of this one. We know that the Y is going to be the depth, so I'm going to say equals bookshelf exclamation mark cabinet depth tab. It's good shape. And then last but not least, we want the sizing in the Z direction, up and down, basically the thickness, to equal the bookshelf exclamation mark MATL thickness. Tab, no exclamation marks, nothing, or no hashtags, no red lettering, no warnings. So we're in good shape. So that takes care of our top and our back. So now what we're going to do is we're going to tackle the middle shelf here, and we're going to apply some formulas that are going to allow us to kind of repeat this as we increase our shelf or our size. So I'll meet you in the next lesson when we tackle our shelf middle piece here.